Okay, hey there, part 3 now. We're almost done. Okay, so just the last part of 1.5 to finish up. So with the orbital diagrams. Okay, so orbital diagrams are they're models that we use to show how the sublevels are filled. So this illustrates Hund's rule. Now really it also illustrates the Aufbau principle, the order in which the sublevels fill up. It also illustrates Pauli's exclusion principle, where we only have 2 electrons in an orbital with opposite spin. So it illustrates all of those. With this, we use boxes to represent orbitals and arrows to represent electrons, and this is what it looks like right here. This is the example for chlorine. So one thing I'll tell you with this, there's really more here than you would need to do. You only need to do the sublevels, or show the sublevels that you would show in the electron configuration. So this 1s, 2s, and 2p, you wouldn't have that. That would just be like the neon in brackets. You don't need to have that. These are called core electrons. So they're like the lower electrons that aren't really involved in anything. Okay, but this does show what it looks like. So this is your 1s sublevel. So it only has the one orbital, and the one box represents one orbital. You can have 2 electrons in each individual box, and you have 1 up arrow and 1 down arrow. Okay. P sublevels, like this 2p sublevel and 3p sublevel. P sublevels have 3 orbitals, so they're going to have 3 boxes. D sublevels have 5 orbitals, so 5 boxes. And if there was F, that would show up with 7 orbitals. Okay. So this is what it looks like for chlorine, and really all you'd have to show is 3s and 3p. Okay. So a 3s sublevel has the 1 orbital, so 1 box with 2 electrons in it, and the chlorine ends 3p5, so this is where those 5 electrons go. And you want to also know the order in which these sublevels fill up. According to Hund's rule, you don't pair up electrons in the same energy level until you have to. So the order in which you place these 5 electrons, the first one goes here, the second one goes there, the third one goes here, the fourth one, now you have to start pairing them up, so that's going to go right there as a down arrow, and the 5th one goes right there. Okay. So that's what chlorine's orbital diagram looks like. Here's a couple of examples for calcium and iron if you want to try those out. Otherwise, I'm going to show the answers for that right now. So again, these photos that I found show all the core electrons. Really, with calcium, you'd only have to show the 4s2, the valence electrons, right? As in what you would see in the electron configuration if you write that out. Because calcium would be argon 4s2, so you just need to see the 4s2. So it's just a 1 orbital with 2 electrons, and that's it. Iron, this is just a different way to show it with just kind of dashes here instead of a full box to represent each orbital. But you see 1s, 2s, 2p, 3s, 3p. Again, these are the core electrons. These do not need to show up in the orbital diagram, but the bottom row here, these are the ones that you would need to see. Because the electron configuration for iron is, it's argon, and then 4s2, 3d6. So you'd want to see these, this part of the orbital diagram right here. So the 4s2 is completely filled, but when you get to the 3d sublevel, iron has 6 electrons in the 3d sublevel, so you start with up arrows in each of those, so that's your first 5, so you go 1, 2, 3, 4, 5, and then in the 6th one, that's when you pair it up in that first orbital. Some questions you'll see with orbital diagrams, you might be asked how many half-filled orbitals some elements have. That's a common question that you see. I mean, if you look at calcium, there's 0 half-filled orbitals, or all the orbitals they're full with their 2 electrons. But now you look at iron, You never have to worry about core electrons, but you look at the D sublevel here, there's 1, 2, 3, 4 half-filled orbitals. So you'll see some questions like that. There's some in the study guide, and they might show up on the AP test also. Okay, so that's it for the section 1.4 and 1.5 notes. All right, have a good day. Bye.